Hello friends, welcome back to the channel. When we talk about semiconductor manufacturing, it starts with silicon wafer cutting, and then there is deposition, and then there is photoresist coating, and then there is most important part is lithography. Then it comes after the etching, then iron implementation, and then the chip packaging. So chip packaging comes in the final stage of semiconductor manufacturing. It is a very important part. So chip packaging is nothing but cutting the chips from the silicon wafer and then interconnect with them. So there are different uses of chip packaging. In chip packaging, we can combine different types of chip. We can combine HBM, high bandwidth memory, with the logical chip. Also, generally in the high performance calculation, and then also high performance computing, and also in the AI applications, these are very fruitful. And especially when there is a very shortage of space, then chip packaging comes very handy to make the functionality within a very stipulated space or area of the chip. So in this video, we talk about why chip packaging is very vital. We talk about different type of technology, that is 2.5D technology, 3D technology, and heterogeneous chip packaging. Also, there are different real-world examples like how TSMC makes the CoWoS, CoPoS, and different varieties of CoWoS type of chip packaging. We talk about all these. So stay tuned till the end of the video to know all the things in detail. So when we talk about chip packaging, we should also discuss about Moore's law. Moore's law says that the number of transistors doubles every 2 years. So that means that Moore has proposed this law in the year of 1965, and even after 50 years, this law still holds good. But the thing is that the law is very slowly dying, because beyond 3 nanometer, it is extremely difficult to put more and more transistor in a small area out there in a 2D area itself. So there is a challenge of technological improvement. So two ways it can be solved. One is basically through lithography way. Lithography, instead of using NAUV, you can use high NAUV machine, by which you can also congest more and more transistor, maybe 2 nanometer or 1 nanometer. But the yield is not guaranteed. So it is still in the experimental way of chip technology. The second way is basically the chip packaging. That means that you do not need to put all the chip in a 2D area. So you can do a vertical stacking of the chips. You can combine the chip in a same silicon substrate, and this way you can do all this type of things. So when we talk about chip packaging, we should talk about what is 2D chip packaging, what is 2.5D chip packaging, what is 3D chip packaging. So 2.5D chip packaging is basically different type of chips you can combine in the same, side by side on the same silicon wafer kind of things. And in 3D is basically you can put the chip in different, in a stack of chips vertically one after another. In that way, you can have silicon interposer in between them to connect them, and then the whole chip you can mount it on a substrate, and you can combine these whole things in a spread areas of other kind of functionality on the board. So we can have 2D. 2D is basically simple. It's a normal chip. You can make the chip technology small as 3 nanometer. That is on the production right now. So these are the things, different type of chip packaging. There are another chip packaging technology which is called heterogeneous chip packaging, where different type of chip technologies combined in a same chip package. So this is very interesting. So now when we talk about real world example, TSMC is the #1 chip manufacturing company, and they are currently using CoWoS. Now what is CoWoS? It is chip on wafer on substrate. So I will not talk in detail, but I will just give a small introduction of CoWoS. It's basically chip on wafer. All the chips are put on the same wafer, and then they are put on the substrate by doing some ball mounting kind of things, and then this chip on wafer is put on the substrate. So in that way, they vertically stack the chips one after another. Then the revised version is CoPoS, which is basically chip on wafer on package. In that way, they put the wafer not as a circle, they put on the square kind of wafer to put more and more chip functionality into the same chip itself. So these are the very interesting things. There are different varieties of CoWoS. So based on the customized need for the customers. So this is very interesting topic, I would say. Now I talked about today what is chip packaging. It is a one part of the semiconductor manufacturing. I talk about why it is important, what are the different usage of chip packaging. I talked about what are the types of chip packaging: 2.5D, 3D, CoWoS, CoPoS by TSMC, the real world example of chip packaging. So what is your thought of it? Now, do you think that a chip packaging is enough to move further chip technology further on the future road, or do you think that using that lithography you can congest more and more chips in the 3 nanometer or 2 nanometer technology? You can put your comments in the comment section of the video. And also, if you like this video, please subscribe this channel so that you can get more and more similar videos on chip technology and semiconductor technology itself. If you like the video, please press the like button. And last but not the least, I would like to say that I have recently published a book called Semiconductor for All. So this is an interesting book where I have put 25 fascinating topics on that. This is related to semiconductor, related to artificial intelligence. I discussed about electronic design automation topics out there, and also there are it is specifically for the semiconductor enthusiastic to semiconductor experts. So consider buying this book from Amazon. I will give a link of the Amazon purchase link in the description section of the video. So I think that's it for today's discussion. So stay tuned for the next video to come. Till then, Subhasish Chakraborti signing off.